You know, artificial intelligence is making some pretty huge decisions for us these days, everything from our health to our finances. But what happens when we can't see how it's making those calls? That's what we're diving into today.
So picture this. You apply for a loan that you really, really need, and an AI system just denies it, instantly. Naturally, you ask why, right? You want to know what you can do better next time. But what if this system literally can't tell you?
Well, for a lot of the most powerful AI models out there, that's exactly the situation. Their inner workings are so incredibly complex that even the people who designed them can't really trace the logic for any one decision. And that is what we call the black box problem of AI.
So why is getting a no comment from a computer such a big deal? I mean, why do we actually need to peek inside this so-called black box? Well, it turns out the stakes are incredibly high.
It really all comes down to four major things. First, you've got trust. I mean, how can a doctor trust an AI's diagnosis if they can't understand its reasoning? Then there's fairness. Without transparency, how can we be sure an AI isn't secretly biased? For the developers, it's a practical thing. You just can't fix what you can't see. And maybe most importantly, safety. When a self-driving car slams on the brakes, we absolutely need to know why.
And that's the bottom line. When we can't comprehend a decision, we can't trust it. And that lack of trust is a huge barrier to using these amazing tools in a way that's actually responsible. So what's the solution here? How do we crack open that black box? Fortunately, there's a whole field of research dedicated to exactly that. And it's called Explainable AI, or XAI for short. The entire goal of XAI is to create systems that can justify themselves, to finally give us that all-important why behind the what. You can think of XAI as the key that unlocks the black box. The big idea here is to completely change our approach. We want to move away from these mysterious, opaque systems and start building transparent ones instead. We're trying to turn that black box into a glass box. Okay, so how do you actually do that? How do you make an AI explain itself? Well, it turns out there are two main ways to get there. So on one hand, you can build what are called inherently interpretable models. This is the glass box approach. You build transparency in from the very beginning. Think of simple things like decision trees, where you can literally follow the logic step by step. On the other hand, you have post-hoc explanations. This is what you do when you've already got a super powerful, complex black box. These are clever techniques you apply after the fact to try and figure out its reasoning for one specific outcome. Now, here's the catch, and it's a big one. There's a fundamental trade-off. Those simple, interpretable models, they give you crystal clear, direct explanations, but they're often not as accurate on really complex problems. The post-hoc techniques let you use the most powerful models out there, but, and this is key, the explanations they give are just approximations. They're an educated guess, not the absolute ground truth. Okay, this might all be sounding a little theoretical, but trust me, XAI is already making a huge difference out in the real world. Let's look at a few examples.
Take healthcare, where the stakes are life and death. An XAI system doesn't just say, hey, there might be a tumor in this scan. Instead, it highlights the exact pixels that made it suspicious. It shows its work. This lets a human doctor immediately see what the AI is seeing, validate it, and work with the AI as a partner. And let's circle back to that loan application from the beginning. With XAI, you wouldn't just get a denied. You'd get a list. Here are the top 3 reasons for our decision. Maybe it was a high debt-to-income ratio or not enough credit history. Suddenly, it's not just fair, it's helpful. It gives you a clear path forward.
Autonomous cars are another perfect example. If a self-driving car suddenly brakes hard, an XAI system can generate a log that says, braked because sensors identified a pedestrian-like shape partially hidden in the shadows. That kind of data is absolutely essential, not just for figuring out what happened in an accident, but for making the system safer over time. So where are we headed? Well, this field is moving at lightning speed, but as we look to the future, there are some pretty big challenges we still need to solve.
And we're right back at that central problem, the trade-off. The constant push for more and more accurate AI usually makes them more complex, which in turn makes them harder to understand. The holy grail for XAI research is to close that gap, to figure out how to get the best of both worlds, incredible performance and perfect clarity.
Which really leaves us with one final big question to think about. As we hand over more and more of our world to these algorithms, what level of explanation are we going to demand? What does a good enough explanation even look like? The answer we come up with is going to define our entire relationship with technology for decades to come.